Good day, everyone. Good day, sir. I am Althea Rachel Carbonilla, and I am with my members, Miss Jane Custodio, Miss Kate Liza Tubo, and Miss Rachel Lalubon. So we are here to discuss our topic, product scheduling. So what is product scheduling? So product scheduling is an important part of production and operations management. It helps companies organize manufacturing activities in order to produce goods efficiently and on time. Production scheduling focuses on planning the use of machines, materials, and workers to achieve company goals while minimizing delays, costs, and wasted resources. So, meaning ani guys is giplan kung kano sa himuon siya kano sa siya himuon ang products, unsang machine ang gamiton, o kinsang assigned workers ang kinahanglan ibutang diri. Important niya siya kay para dili ma-delay ang production. And now, let's continue to production planning. So production planning is one of the major steps in managing the supply chain. It focuses on predicting the level of manufacturing output based on expected sales, company objectives, and available sources. Instead of concentrating on individual products, production planning groups products into families according to similarities in design, manufacturing processes, and resources requirements. This helps companies forecast demand, manage materials, and improve scheduling efficiency. So, when we say production planning is mo ni siya ang production nga kana ma-process ang pagplano kung pila ka products ang himuon based as expected demand sa customer. So, dili lang kay bitaw siya guys, dili lang kay basta maghimo or kanitang so kanisiya si ma'am kanang 100 ni ka pieces atong gamon, di ba? Dili lang basta maghimo guys. Diba guys, mas madali yung trabaho if like sundon ninyo ang rules sa production planning. That's why we have production planning para mag-plan ka sa step by step, no? So, that is production planning. So next, let's continue to loading. Loading refers to the process of assigning work to machines or manufacturing processes. It is performed during capacity requirements planning, or CRP, where workloads are measured according to setup time and operating time. Loading helps determine how much work each process or machine can handle within a specific period. So, kaning loading is mo ni siya ang kanang pag-assign mo work sa isa ka employee or sa workers o machine. Kaya muna bitaw, muna siya ang makatabang nimo nga mahuman on time ang imuhang trabaho. And para mo sa niya makatabang nga ma-determine diri kung pila katrabaho ang kayang buhaton sa usa ka machine. Sulod sa certain time, di ba? Para ka nang kintahay ba, madali inyong job, madali inyong trabaho kay syempre dili kanang magamatag product is like inoras man na or kanang dapat within that time man na mo ay kanang pila ang makaya sa machine nga mahuman within that time. So mga tong sa pinaagi sa proper loading, mahimong balance o smooth ang operation sa company or sa inyong paghimo sa product. And now, let's continue to sequencing. So sequencing is a process of arranging jobs on machine in the best possible order to minimize production time, reduce cost, and maximize the use of resources. In production system, many jobs compete for the same machine and workstations, making sequencing necessary for efficient workflow. So, kanin di ay kuan guys, sequencing is muna siya ang makapa-arrange ba sa mga job and task na naasa saktong order. Kung walay proper nga sequence, no, kay magka-delay-delay niya siya sa production. Ang goal sa sequencing is mapaspas ang trabaho, ma-minus ang cost, and maximize ang paggamit sa resources. So now guys, we have sequencing, sample, problem, and solution. So here is let n number of jobs and number of machines. So then, theoretically possible sequences is sitawagan na guys. Kanang may kanang open and close parentheses. And then ay n, pag nasa exclamation mark, o kanang m sa babaw. So, ang tawag ana is n factorial raised to the power of n. So, n factorial raised to the power of n. So, if n equals 4 and m is equals 3, then number of sequences is 4 factorial raised to the power of 3 kay mama na dili is equals to 16,777,216.
So we have here the proper solving for the given sample and the sequencing. So here guys, nakita na to is nag-start siya sa n factorial raised to the power of m, where n is equals to number of jobs and m is equals to number of machines. So we have here the given. N is equals to 4 jobs, m is equals to 3 machines. So i-substitute na to guys. So muna na siya 4 factorial raised to the power of 3. Then first solve the factorial. So makita na to diri guys is nganong 4 times 3 times 2 times 1 is because dapat kung unsa may kanang given nga factorial guys is ato dyan mo mag-start then mag-end mo sa 1. So example, if given nga factorial is 6, so mag-start mo sa 6 and mag-end gyapon mo sa 1. So example na is kaning sa 4. So 4 times 3 times 2 times 1. So if example sa 6 is 6 times 5 times 4 times 3 times 2 times 1. So yan na siya guys. And then mo to, inyo na siyang i-calculate, mo na siya magawas 24. So if unsay magawas dira is mo na siya ang erase third power. So 24 times 24 times 24 equals 13,824. So therefore the total number of possible sequences is 13,824. So medyo naalay mga medyo nasayop siguro itong nasa book. And that's how we solve the sequencing.
Okay, now so let's continue to priority sequencing. So priority sequencing is a method used when several jobs are waiting to be processed on the same machine or work center. In this method, jobs are assigned according to priority rules so that the most important or urgent jobs are completed first. So, ano siya guys is, ang example dili is kung kintahay na yung mga customer na nag-order, then gusto sila nga madali sila, kay syempre ilang kinahanglanon no. So, nilakatabang na para ma-manage ang workloads o para ma-maintain ang smooth production flow. So now let's continue to sequencing problems. So sequencing problems occur when companies need to determine the best order for processing several jobs using different machines or facilities. The goal is to minimize total processing time while maximizing efficiency and profit. So when we say sequencing problem no kay muna siya ang mahitabo kung lisod na i-determine unsang job ang dapat unahon sa machine. Like, kintahay, if kanang medyo nabitang nagdaghan ng mga possibles nga combinations para i-arrange ang job is maglisod na dyan ang machine na nag-handles. And isa pod is himusat o kanang scheduling if really nag-complicated na dyan ba kay syempre if inyong i-over masyag madaot and masyag ma-overuse. So now let's continue to basic assumption and sequencing. So sequencing problems are based on several assumptions Only one operation can be performed on a machine at the time. And processing time are fixed and known in advance. Job must follow a specific order, and once an operation begins, it continues until completion. So, pasabot na guys is muna siya ang kanang madali siya og manage. So, pwede sa doog kanang i-fix known na daan ang process time, and then kinahanglan sundo ng specific order sa job. So now, let's continue to sequencing models. So, it is used to organize the job depending on the number of machines involved in production. So, these models include sequencing several jobs on one machine, two machines, or multiple machines. So, the purpose of these models is to improve efficiency, reduce production time, and help companies achieve better operation performance. So, very understandable siya kayo, no, guys, no? Para kanang iwas delay, para improve sa paggamit og mga machines, madali siya, and kanang mas efficient siya. So, that will be all my topics, sir. Thank you.
I am Baby Jin Seiko Studio, and today I will be discussing the sequencing and jobs on one machine using the SPT rule, or shortest processing time rule. Now, let's move to number 2. Sequencing jobs on 2 machines. Number 3, sequencing jobs on 3 machines. And number 4, sequencing jobs on M machines. Sequencing means arranging jobs in the best order to improve efficiency, reduce waiting time, and minimize delays in productions. There are 5 rules used in sequencing. First, SPT rule, or shortest processing time. Second, WSPT rule, or weighted shortest processing time. EDD rule, earliest due date, and Hodgson algorithm, and the last is slack rule. To illustrate above rules, an example is being considered. Example, considered 8 jobs with processing times, due dates, and important weight as shown below. Time is performed first. In this rule, job with shortest processing time is considered first, then next, and so on. It simplify means that arranging processing time in ascending order, the job sequence could be found. Using SPT rule, the sequence of jobs will be 4 minus 8 minus 1 minus 3 minus 7 minus 2 minus 5 and minus 6. Completion time is found by adding the previous completion's time and current processing time. Example, job 4 finishes at 3, job 8 finishes at 6 because 3 plus 1 equals 6. Job 1 finishes at 11 because 6 plus 5 equals 11. Mean flow time formula. Mean flow time equals 3 plus 6 plus 11 plus 17 plus 24 plus 32 plus 42 plus 56 over 8 equals 23.9. Mean flow time is the average time all jobs spent in the system. The total completion time is 191, then divide by 8 jobs. Second, weighted mean flow time. 1 close parenthesis 3 plus 1 6 plus 1 11 and so on over 15 equals 29. This formula considers the importance weight of each job. Jobs with higher weight are more important, so they affect the result more. Number 3, average in the process inventory equals 8, 3 plus 7 plus 3 plus 6, 5 plus 5, 6 plus 4, 7 plus 3, 8 plus 2, 10 plus 1, 14 over 56 equals 191 over 56 equals 3.41 jobs. Average inventory shows the average number of jobs inside the system during the production. Number 4, waiting time for each job. Waiting time means show how long a job waits before processing starts. Example, job 4 waits
0 because it starts immediately. Job 8 waits 3 units because job 4 finishes first. Mean waiting time. 0 plus 3 plus 6 plus 11 plus 17 plus 24 plus 32 plus 42 over 8 equals 16.875. Add all waiting times and divide by the total number of job means waiting time equals 16.875 units. Now, I will discuss the lateness of each job using the SPT sequence that we previously computed. Number 5, lateness of each job equals completion time of job minus due date of job lateness helps determine whether a job is completed early or late compared to its due date. Lateness of job 4 equals 3 minus 25 equals negative 22. Lateness of job 8 equals 6 minus 50 equals negative 44. Lateness of job 1 equals 11 minus 15 equals negative 4. Lateness of job 3 equals 17 minus 15 equals positive 2. Lateness of job 7 equals 24 minus 45 equals negative 21. Lateness of job 2 equals 31 minus 10 equals positive 22. And the last is lateness of job 6 equals 56 minus 40 equals positive 16. The formula of lateness is Li equals Ci minus Di, where Ci equals completion time of the job, Di equals due date of the job. If the answer is negative, the job is completed early and the positive job is delayed or tardy. Mean lateness equals negative 22 minus 44 minus 4 plus 2 minus 21 plus 21 plus 22 plus 16 over 8 equals negative 3.625. We add all lateness values and divide by the total number of jobs. Mean tardiness equals 0 plus 0 plus 0 plus 2 plus 0 plus 2 plus 2 plus 22 plus 6 over 8 equals 7.8. Only positive lateness values are included because tardiness refers only to delayed jobs. Number of tasks actually late equals 4 job number 3256 equals number of tardy jobs. Maximum lateness equals 22 units, job 5 and 2 both. WSPT rule in the rule job with the shortest processing time per unit of importance is considered first, then next, and so on. It simply means that arranging processing time per unit of importance in ascending order, the job sequence could be found. Next, I will discuss the WSPT rule or weighted shortest processing time rule. In this rule, jobs are arranged based on the ratio Wi over Ti, where Ti equals processing time, Wi equals the importance weight. The smallest ratio is prioritized first. After arranging the ratios from smallest to largest, the sequence becomes 3 minus 4 minus 8 minus 7 minus 2 minus 6 minus 5 minus 1 minus 5 respective flow time equals 6, 9, 12, 19, 27, 41, 46, 56. Mean flow time equals 6 plus 9 plus 12 plus 19 plus 27 plus 41 plus 46 plus 56, 216 over 8 equals 27 units. Weighted mean flow time equals 3, 6 plus 1, 9 plus 1, 12 plus 2, 19 plus 2, 2, 7 plus 3, 41 plus 1, 46 plus 2, 56 over 3 plus 1 plus 1 plus 2 plus 2 plus 3 plus 1 plus 2, 412 equals 27.47 units. Similarity means lateness equals negative 0.5 mean tardiness is equals to 10.6. So that ends my reporting. Thank you, sir.
Good day, everyone. Today, I will be discussing the EDD rule, or earliest due date rule. EDD rule is a scheduling techniques where jobs are arranged according to the due date, with the earliest deadline is processed first. These rules is mainly minimize maximum lateness in production scheduling. In our example, the sequence of jobs becomes 2, 1, 3, 5, 4, 6, 7, 8 because job 2 has the earliest due. After applying the EDD rule, we obtain the following results. The time is, while the weighted mean flow time is 1.7. The mean lateness is positive 4.5 units, and the mean tardiness is 6. The maximum lateness is 9 units. There are also 6 late jobs, specifically jobs 3, 5, 4, 7, and 8. This means that though EDD minimized, many jobs are still completed late. Hudson's This algorithm will minimize tardy jobs. It is only applicable if there is more than one tardy job after using the EDD rule. Since the EDD six tardy jobs, Hudson's algorithm can be applied to improve the schedule. This table shows the jobs arranged according to EDD rule together with their processing time, completion time, due date, and lateness. Job 3 is identified as the first tardy job because lateness become positive 4. According to Hudson's algorithm, we end up jobs before the first tardy job and remove the one processing. In this case, job has the longest processing time of the final difference using Hudson's algorithm is 1, 4, 6 to 5. The mean lateness becomes 1.625 while the number of tardy job is reduced from 6 to only 2. This shows that Hudson's algorithm is very effective in late jobs. Now let's discuss the slack rule. Slack time is computed by subtracting processing time from the due date. Jobs with the smallest slack are processed because they have less time before the deadline. Shows the processing time during slack time job. After arranging the jobs according to ascending slack time, the sequence helps reduce tardiness in scheduling operation. Using the times are 8, 14, 19, 32, 46, 53, and 56. The mean tardiness is 5, the mean flow time is 32.1, and the flow time is 31.1. This rule is effective in minimizing average tardiness. This table compares different scheduling method. SPT minimize mean flow time, while WSPT consider job weights. EDD minimize maximum lateness. Hudson's minimize the number of tardy jobs, and slack rules minimize mean tardiness. This compartment identifies is best depending on the objective of the company. Next is sequencing and jobs on two machines. In this problem, each job passes through machine A and B to the main sequence that minimize total time and ideal time. Job algorithm only solve this. Step is the smallest processing time among all jobs. If the smallest belongs to machine, the job is at the beginning of this. If the times belongs to B, the job is at the sequence. Press seated until all jobs are arranged. After arranging all jobs, lapse and machine ideal time, the algorithm create an efficient schedule by minimizing waiting and ideal time. Now let us discuss sequencing jobs in machines. Case, every job must pass through machine 1, machine 2, and machine 3 in the same order. Johnson's method can still be applied if certain conditions are satisfied. Two conditions to apply Johnson methods for 3 machines. First, the smallest processing time on machine 1 must be greater than or equal to the largest processing time on machine 2. Second, the smallest processing time on machine 3 must also be greater than or equal to the largest processing time on machine 2. If at least one condition is satisfied, the problem can be converted into a 2-machine problem. To convert the problem, 2 fictitious machines are created. After conversions, Johnson's algorithm for 2 machines is used to determine the optimal sequence. Tie-breaking rules. Lastly, we have the tie-breaking rules. If 2 jobs have equal smallest processing times on different machines, one job is placed at the beginning while the other is placed at the end of the sequence. If the equal times are both on machine 1, the job with a smaller machine 2 processing time is placed first. These rules help avoid confusion when arranging.
Good day everyone, I am Kate Laisam Tubu and this is my part of reporting. It is a method used to determine the best sequence of jobs in order to minimize total processing time and machine idle time. For the 2-machine problem, the procedure starts by selecting the smallest processing time among all the jobs. If the smallest processing time belongs to machine A, the job is placed first in the sequence. If the smallest processing time belongs to machine B, the job is placed last in the sequence. After placing the job, it is removed from the list, and the same process is repeated until all jobs are arranged. Finally, the total processing time and idle time of the machines are computed. Now, let's move to sequencing of n jobs on 3 machines. In this case, every job passes through 3 machines in this order: M1, then M2, then M3. Johnson's method can still be applied if at least one of these conditions is satisfied. The smallest processing time on machine 1 is greater than or equal to the largest processing time on machine 2, or the smallest processing time on machine 3 is greater than or equal to the largest processing time on machine 2. To solve the problem, the 3 machines problem is first converted into a 2 machine problem by introducing 2 fictitious machines, G equal M1 plus M2, H equal M2 plus M3. After converting it, generator for 2 machines is applied to determine the optimal sequence. Then, the minimal total elapsed time and machine idle time are calculated. Then, there are also tie-breaking rules. If equal smallest processing times occur on both machines, the job on machine 1 is placed first, while the job on machine 2 is placed last. If the equal smallest times are both on machine 1, the job with the lower processing time on machine 2 is placed first. A work breakdown structure is a hierarchical breakdown of all the work needed in a project. It helps organize project activities into smaller and more manageable tasks. The main purpose of WBS is to make project planning, management, and monitoring easier. In creating a WBS, the process usually starts from the highest level, which is the main project goal or product. Then, the work is divided into smaller parts through a process called decomposition. Decomposition means breaking down large tasks into smaller and more manageable components. The smallest parts is the WBS are work tasks or work packages. For example, in a toy development project, the project may include marketing activities such as brochures, advertising, and commercials. These smaller tasks are easier to assign, manage, and monitor. In project management, higher tasks that contain smaller tasks underneath are called summary tasks or control accounts. Another important concept in WBS is the task owner. A task owner is the person responsible for managing and reporting the progress of a specific task. If a task is too large or difficult to manage, it can be further divided into smaller tasks for better monitoring and control. Overall, work breakdown structure is important because it organizes project work clearly, assigns responsibilities, improves monitoring, and helps ensure that the project is completed successfully and efficiently. So that's all for my reporting. Thank you.